Hello everyone, welcome back to our channel Problematical. Today we'll start with exercise 2.1, second chapter of relations and functions, class 11th maths ncert. The first question is, if x upon 3 plus 1 y minus 2 upon 3 is equals to x 5 by 3 1 by 3. So two ordered pairs are given and they are said to be equal. X upon 3 plus 1 y minus 2 upon 3. This is first ordered pair. It is said to be equal to second ordered pair 5 by 3, 1 by 3. So two ordered pairs are said to be equal when their corresponding elements are equal. That means the first element of the first ordered pair should be equal to the first element of the second ordered pair, and second element of the first ordered pair should be equal to second element of the second ordered pair. That means x upon 3 plus 1 is equals to 5 upon 3 and y minus 2 upon 3 is equals to 1 upon 3. This is the meaning of the given statement. This is given. Therefore, x upon 3 will be equal to 5 by 3 minus 1 and y is equals to 1 by 3 plus 2 upon 3. X upon 3 is equals to 2 upon 3. 3 gets cancelled and y will be equals to 3 upon 3, which is equals to 1. So ultimately you get x is equals to 2 and y is equals to 1. These are your required values. Next, if the set A has 3 elements and set B has 3, 4 and 5, these elements, then find the number of elements in A cross B. Now the A cross B is Cartesian product of A and B sets. Number of elements in A cross B is equals to number of elements in A multiplied by number of elements in B. It's given in the question that number of elements in A is 3 and B set is given which has 3 elements. So number of elements in set B is also 3. 3 into 3 is 3 into 3 is 9. So number of elements in A cross B will be equal to 9. Next, if G is given, H is given, you have to find G cross H and H cross G. G is given to be 7, 8 and H is given to be 5, 4 and 2. Therefore, G cross H will be equal to, it's a set of ordered pairs with G and H. The first element of every ordered pair will belong to G and the second element of every ordered pair will belong to H. So the first element, this set or Cartesian product of G and H are represented in the form of ordered pairs. 7 from G, first element from H, 7, first element of G, second element of H, first element of G, third element of H. Now all the elements of H are covered with the first element of G. Now we'll jump to the second element of G with first element of H, second element of G, second element of H, second element of G, third element of H. This covers all the elements of G cross H. H cross G, we'll first have to write the element in H. So first element of H, first element of G, first element of H, second element of G. Now all the elements of G are covered with the first element of H. So second element of H, first element of G, second element of H, second element of G, third element of H, first element of G, and third element of H, second element of G. These are the values of G cross H and H cross G. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. So the first statement is, if P is m, N and Q is n, M, then P cross Q is. Now this can be understood by observation that it's incorrect because P has 2 elements, Q has 2 elements, so P cross Q should have 2 into 2 is 4 elements. But P cross Q here has 2 elements, first ordered pair and second ordered pair. So let's calculate P cross Q. It's mentioned that if the statement is false, you have to rewrite the correct statement. So if P is equals to m, N and Q is equals to n, M, then P cross Q will be equals to first element of P, first element of Q, first element of P, second element of Q, second element of P, first element of Q, second element of P, second element of Q. All the first elements belong to P and second elements belong to Q. So as you can see, there are 4 elements. Second, if A and B are non-empty sets, then A cross B is a non-empty set of ordered pair x, y such that x belongs to A and y belongs to B. What does this statement mean? The statement means that A and B are 2 non-empty sets. So let's consider 2 non-empty sets just to understand whether the statement is true or false. A can be considered as 1, 2 and B can be considered as 3, 4. These are non-empty sets. They have elements in it. Then A cross B is a non-empty set. By default, you'll have 4 elements in A cross B of ordered pairs x, y. So x, y, this is A, B. A cross B is an ordered pairs of x, y such that x belongs to A and y belongs to B. This is also true because the first element of ordered pair should belong to A, x belongs to A, and the second element of ordered pair should belong to B. So this statement is true. Third, if A is given as 1, 2, B is given as 3, 4, then A cross B intersection phi is phi. Now let's try and understand this. A is given to you, then this is given. Let's directly calculate A cross B intersection phi. We know that first we have to solve the bracket. In the bracket, what is common between B and phi? Phi is a null set. And B is 3, 4. There's nothing common in it. So this is equals to phi. What is A cross phi? If any of the 2 value sets of your Cartesian product is phi, then you cannot form the ordered pairs because A is a set of 1, 2, but phi is a null set. So 1, what? If you want to write the ordered pair, 1, you have to write the elements of second set. There is no element in second set, so the ordered pair cannot be formed. So A cross phi will be equal to phi. Another way of looking at it is number of elements in A is 2. And number of elements in phi, it will always be 0. We know that number of elements in A cross phi should be equal to number of elements in A into number of elements in phi, which is equals to 2 into 0. So you have 0 elements in A cross phi. That's why it is a null set. So this statement is true. Next, if A is equals to -1, 1, then what is A cross A cross A? Now A cross A is equals to, let's write it in a generalized form. A cross B cross C is equals to an ordered triplet x, y, z such that your x belongs to A, y belongs to B, and z belongs to C. So these elements x, y, z are belonging to the 3 sets that we are multiplying. Here, all of them are same. So A is equals to, it's given that -1, 1, B is the same and C is the same. Just for understanding, we'll write A thrice so that we can form these ordered pairs. So A cross A is an ordered pair x, y, z. So first element of this -1, first element -1, first element -1. Second, let's consider these 2 as same, static, and you'll change the for the third element. Next, take first -1. Now consider the second element of A, and with that consider both the elements of A here. -1, 1, 1. Now second element from the first, 1, first element -1, first element, 1, -1, 1, second, first, second, 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 and then first and second of those. Okay. So there are two elements over here, 2 elements over here, 2 elements over here. Are we left with anything? 2, 4, 6, 8. No. So 2 elements over here, 2 elements over here, 2 elements over here. Multiply them, you get 8. So there should be 8 elements here in A cross A cross 8. 1, 2, 3, 4, 5, 6, 7, 8. Number of elements of A cross A is equals to 8. You had to only find these elements. That means this is your required set. Next, if A cross B is given, you have to find the elements of A and find the sets A and B. It's given that A cross B cross C, A cross B is equals to A comma X, A comma Y, B comma X, and B comma Y. We know that A represents the first elements of ordered pair. So A can have either of the values A or B. A is a set of 2 elements A comma B. B is the second value of the Cartesian product. So it will take the second value of your ordered pair, X and Y. X comma Y, which is your required answer. Next, A and B set, A, B, C, D sets are given. You have to verify these. So first value. For this verification, you'll first write LHS. LHS is equals to A cross B intersection C. This is equals to A cross. What is B intersection C? What is common between B and C? 1, 2, 3, 4, and 5 and 6. There is nothing common between B and C. So this value will be equal to 5. We know that A cross 5 will be equals to 5. RHS. RHS is equals to A cross B intersection A cross C. Now let's calculate A cross B. A cross B. So A cross B can be written as 1, 1 first elements, 1, 2, 1, 3, 1, 4, then 2, 1, 2, 2, 2, 3, 2, 4. This is your first set. Intersection, second set A cross C. A cross C. So it is 1, 5, 1, 6, 2, 5, 2, 6. There is not, if you observe these two sets, there is nothing common. No ordered pair is exactly the same. And 2 ordered pairs can be same if both of their corresponding first elements are equal and their corresponding second elements are equal. So nothing is common, it is 5. From 1 and 2, LHS is equals to RHS, hence proved. Second, A cross C is a subset of B cross G. So let's calculate this. B cross D separately. B cross D would be 1, 5, 1, 6, 1, 7, 1, 8. Then 2, 5, 2, 6, 2, 7, 2, 8. 3, 5, 3, 6, 3, 7, 3, 8. 4, 5, 4, 6, 4, 7, 4, 8. A cross C. A cross C is 1, 5, 1, 6, 2, 5, 2, 6. It says over here, this A cross C is subset of B cross D. This is only possible if all the elements of A cross C are present in B cross D. Let's check. A comma 5. This element of A cross C is present in B cross D. A comma 6, A comma 6, sorry, 1 comma 6, 1 comma 6, 2 comma 5. Where is 2 comma 5? 2 comma 5, 2 comma 6, 2 comma 6. So all the elements of A cross C are present in B cross D, which means that A cross C is a subset of B cross D. Next, let A and B are given. Write A cross B. How many subsets of A cross B? How many subsets will A cross B have? List them. Now, first we have to write A cross B. So let's find that. 2 elements in each, so you'll have 4 elements over here. 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4. How many subsets of A cross B have, and you have to list them. Now we know that if a set, if set D, or if number of elements in set D is equals to small m, then power set of D will have 2 raised to power m elements. What does this mean? Power set of D includes all the subsets. The elements of power set of D is subsets of D, all the possible subsets. You have to find how many subsets will this have. Now here, using the same formula, number of elements in A cross B is equals to 4. Therefore, how many subsets means your power set. Power set of A cross B will be equals to the number of elements, or number of elements in power set. Sorry, number of elements in power set. Number of elements, not elements, subsets. Number of subsets of A cross B. This is equals to 2 to the power 4, which is equals to, here you can either calculate directly or you can write it 2 squares square. If you do not know how to do that, it is 2 into 2 into 2 into 2. So 2 4 times 16. Next, list them. You have to list all these 16 subsets. So let's start with the smallest subset. Subsets of A cross B. 5 is a subset of every set. Singleton elements, set of single elements. Single elements would be each ordered pairs. So 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4. Then 2 elements, 1 comma 3, comma 1 comma 4, 1 comma 3, comma 2 comma 3, 1 comma 3, comma 2 comma 4. The trick here is first these two, and these two. Then forget about 1 comma 3, these two and these two, and then forget about 1 comma 4, last these two. These are all the combinations of pairs of elements that you can form, which are subsets of your A cross B. So 1 comma 3, 1 comma 2 comma 4, 1 comma 3 now is to be discarded. Start with the second element, 1 comma 4, 1 comma 4, comma 2 comma 3, 1 comma 4, comma 2 comma 4. Now forget about 1 comma 4, take the next value, 2 comma 3. Only one other value is left, 2, 4. These are all the pairs. Now consider 3 elements. Let's keep first and second static. First and second static. Change the third one. There are 2 options for third one. Either this or 2, 4. Right? Now, first 2 are taken static. Next, you can consider first and third. So 1, 3 and consider 2, 3. With this, forget about 1, 4 because 1, 3 and 2, 3 already has the third element is 1, 4. The other one combination would be 2, 4. Now forget about the first element 1, 3. Take the second and third elements. 2, 3, third element 1, 4, second element, and the last element 2, 4. These are all the combinations of 3 elements that you can form. The elements of 4 combination, a set is a set of itself, a subset of itself. Let's check whether we have 16 or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these are all the subsets, 16 subsets of A cross B. Next, let A and B are 2 sets such that number of elements in A and B are given. If this is x, 1, y, 2, z, 1 are in A cross B, they are present in A cross B. Find A and B where x, y, z are distinct elements. What does this mean? You're given that number of elements in A is 3. You're also given that number of elements in B is 2. You're given that A cross B is a set and some of its elements are x, 1, y, 2, z, 1, and dot so on. We do not know the rest. We know that number of elements in A is 3 and number of elements in B is 2. So total number of elements in A cross B should be 3 into 2, which is 6. So out of 6 elements, 3 elements are given to you. We know that the first element should belong to A. So your A set should have at least values x, y, and z. And what about your B? The second value should be B. So B is equals to 1, 2. Now the number of elements of A is 3, which is satisfied here, and number of elements in B is 2, which is also satisfied. So these are your final values of set A and B, which is required. Find A and B. Next, the Cartesian product A cross A has 9 elements. So number of elements in A cross A is equals to number of elements in A multiplied by number of elements in A. And this value is given to you as 9. So this is number of elements in A whole square is equals to 9, which means number of elements in A, 9 can be written as 3 square, will be equal to 3. The Cartesian product this has 9 elements, among which are found this and this. So among which means that number of elements in A, sorry, not number of elements, A cross A. A cross A is a set and 2 of its elements are this and this. Out of 9 elements, 2 elements are known to you. What are you supposed to do? Find set A and the remaining elements of A cross A. So first we'll find set A. We know that the first elements belong to first value, first set over here. So A is equals to -1, 0. These are elements of A. Now the second set is also the same, which has 0 and 1 in it. So 0 is already written, 1 is written over here. We know that A has number of elements A is 3, which means A is this required set with 3 unique elements. Now you have to find the other elements of A cross A. Now based on this A, let's rewrite A cross A. This will be equal to -1, -1, -1, -1, 0, -1, 1, 0, -1, 0, 0, 0, 1, 1, -1, 1, 0, 1, 1. So this is A cross A and the remaining elements. This concludes in this exercise. Thank you.